Electric field due to electric dipole at any general point. General point means the point which is not at axial axis of the dipole and not on any equatorial line. This is general point. And the benefit of studying general point is if you study and remember the formula at the general point, you can find the field at any point and their direction also. So how we can derive and what is the formula, what is the direction, what is the angle making by the net electric field with the position vectors, with the axis, we can see all this in these derivations. Okay, so let's start. This is what we know. Dipole is the combination of two equivalent opposite charge. Dipole is the combination of two equivalent opposite charge. This point is A and this point is B, right? Either this point is A and B. This is the center of the dipole and this is the separation. It means length of the dipole. Okay, so any general point is this. This is what? General point P. General point P is its separation. Position vector of point P from the center of the dipole is R vector. Okay, this is the direction of dipole moment, P vector. And position vector is making angle theta with the dipole moment. Okay, so if we'll change this position by some angle, this is P and this is A. This is what? P to A. What is this is? This is dr. And if we change in this direction A to B, this will becomes here we can write this is d theta. We know relation between field and potential, right? If we have potential is known given, like at general point potential is Kp cos theta by r square. If we differentiate it with respect to position, with respect to r, we'll get electric field. Any problem? So this point is P, this point is A, and this is the length which is actually r d theta. This is r, no, this is r, this one is r, this length is r d theta, right? So this is called E radial and this is called E transverse. With the variation of theta we can write theta. So net field is the vector sum of these two. Vector sum of ER and E theta. This is E. Okay, and this is angle alpha, which we sometimes need to find. This is E. Okay, we have what we have? We have potential at general point. We have potential at general point. What is the value of potential? This is V. We can write Kp cos theta by r square. So if we will change this point along, if you will change r along the line away or towards, this point, this point, this point, this point, this point, this point, you can see theta is not changing. When you are varying r along the line, theta is not changing. So differentiation of V with respect to r, assuming theta is constant, is called partial differentiation of V with respect to r. And we have what we know, E radial equals to minus delta V by delta r, partial differentiation. So delta V ER we can write minus delta V we can write Kp cos theta by r square by delta r. So if we'll take constant out of the differentiation, we can write Kp cos theta. Now we can write total differentiation of 1 by r square by dr. So we can write over here er equals to minus kp cos theta into r to the power minus 2 we can write now. R to the power minus 2, what we can write? Minus 2 r to the power minus 2 plus 1. What we can write? Minus 2 minus 1, that is minus 3. So students, radial component of vectors minus minus plus, that is 2 kp cos theta by r cube we can write. Any problem? No problem. Chaliye. Next we can see e theta. If we change transversely from this radial line the position, this is the position change. Right now, this is the position change. This position change we can write over here, right? E minus delta V, right? We can write minus delta V by r delta theta. Because if you change like this, na, r will be same, but theta will be changed. So while differentiating with respect to theta, with respect to variation of theta, r assumed to be constant. We'll take r is constant. So we can write e theta equals to minus 1 by r into partial differentiation of this value, that is kp cos theta by r square by delta theta. So e theta equals to minus 1 by r into kp by r square, we take common, delta cos theta by delta theta. You can write it as complete derivative also, right? So if partial right, you are writing partial, there is no initial, एक ही variables है theta. So e theta will be minus kp by r cube. Differentiation of cos theta is minus sin theta. Minus sin theta. Write this as equation 1. Then e theta equals to minus minus plus, you can write kp sin theta by r cube. Kp sin theta by r cube. This is equation 2. Any problem up to here? No problem. This is kp 2 kp cos theta by r cube. This is kp cos sin theta by r cube. Done? From here, what we can write? Net electric field. What is net electric field? Net electric field, this one na, and this electric field is, magnitude is vector sum of er and e theta, that is er square plus e theta square. So e net we can write, what? We can write e net is visible, actually less visible. So we need to erase from this side because this part is not completely visible. So we need to see complete the things. You can pause and understand. If anyone having any doubt, you can write in the comment, and also you can ask me any doubt regarding this derivations and this concept and this effectiveness, right? Here we can write E net. E, we can write what? E r square plus E theta square. This E equals to, we can write ER, you can say 2 kp cos theta by r cube whole square plus kp sin theta by r cube का whole square. So E we can write kp by r cube is common na, and square root is cancel out each other, so kp by r cube we can take out of common out of both and out of square root. So here it will remaining 2 cos theta whole square plus sin theta whole square. So E equals to kp by r cube under root 4 cos square theta plus sin square theta. So E we can write kp by r cube, we can write here 3 cos square theta plus cos square theta plus sin square theta. You can write 4 cos square theta, what we can write 3 cos square theta plus cos square theta, and cos square theta plus sin square theta is 1. So we can write over here kp by r cube under root, इसकी वैल्यू we can write 1 plus 3 cos square theta. This is the value of formula of electric field at any general point due to dipole. Okay, so this is electric field at any point, general point due to dipole. This is the value So what is R? R is the position vector from the center of the dipole to the point, from the center of the dipole to the point. Okay, so here E and 10 alpha, we can see what is the direction of electric field, what is the angle between the electric field and the position vector, that is 10 alpha na? 10 alpha you can say E theta by ER, that is 10 alpha equals to E theta. E theta is what? kp sin theta by r cube. What is ER? That is 2 kp cos theta by r cube. This kp r cube. So 10 alpha equals to 1 by 2 sin theta by cos theta. So students, you can write 10 alpha equals to 1 by 2 10 theta. Any problem? So alpha we can write 10 inverse 1 by 2 10 theta. This is the general point. Students, keep in mind, this is the field at general point. Okay, what is the formula? kp by r cube bracket में under root 1 plus 3 cos square theta. Okay, so this is r, this is r. If you will take this, this is r. If you will take this, this is r. If you will take this, this is r, and theta will becomes this, right? You can theta with the dipole moment only, right? You need to take theta from with the dipole moment only. So this is the value of electric field at any general point, right? So you can pause over here and you can write, you can understand. In case of any doubt, you can ask, feel free to ask. Okay, this is the value at general point, and general point we alpha will represent the direction of electric field, right now, net electric field, and the value is the magnitude, that is kp by r cube bracket under root 1 plus 3 cos square theta. Now we have what? E equals to how much? That is kp by r cube 1 plus 3 cos square theta, and 10 alpha equals to 1 by 2 10 theta. Now we'll study special case. Special case. General point means the formula will be valid for all the points. In case of 12th board examination, this general point derivation is not asked. This is not in syllabus in 12th board. But this is very important for the mains, advanced and NEET examination. NEET less important for NEET, but the mains and advanced, the questions can be asked directly. If you understand this properly, you can solve the proper questions which is asked on this concept. Okay, so special case means, special means especially axial और equatorial point की बात करेंगे. We'll speak about the, we discuss about the general point. Like first point लिखेंगे case first. What is the case first? लिखेंगे, right? Electric field, at axial point. Where? Axial point. The thing is, what is axial point? Axial point, which is the point lies on the axis of the dipole. This is minus q, this is plus q, and this is axis. This whole is axis, either this side, either this side. Any point, at any point, we can write this is P, and this is the point P. Don't confuse, this P is dipole moment, this is just a point P, and this is the separation R. You can see R here, theta. This is R vector and this is P vector. So theta is what? 0. In this case, because general point is this now, this is angle making theta. If you will come, this point will reduce, shift to the equatorial point, theta will become 0 with the dipole moment. Okay, so we can write E equals to Kp by R cube 1 plus 3 cos square 0. Cos square 0 is 1 na, so we can write Kp by R cube bracket में 1 plus 3 cos square 0 equals to 1. So E, we can write Kp by R cube under root 4. So E equals to 2 Kp by R cube. So you can write over here E equals to 1 by 4 pi epsilon naught 2p by R cube. R is the separation of point P from the center of the dipole, and P is the QD, which is the dipole moment. And also you can write theta, direction. What is the direction? You can write tan alpha equals to 1 by 2 tan theta, tan 0. So this is 0 now, tan alpha equals to 0. So alpha equals to also 0. It means, hence, the angle between field vector and dipole moment vector is 0 at axial point. Is 0 at axial point. Okay. Done everyone? This is 2 Kp by R cube on axial point, and theta, direction of electric field, is in the direction of dipole moment. Where? At axial point. How we get to know? We get to know from theta, from alpha. Okay, this is special case 1. Now the special case 2. Special case 2, we will study diagram. We can keep this one only, and point will shift at equatorial. Case 2, students will write case 2. So electric field due to dipole at equatorial point P. Okay, on equatorial point P. This is the equatorial point P. So you can see this is R vector, this is P vector, and this angle is what? 90 degree. So what we can write? For axial point, for equatorial point, theta equals to 90 degree. So E general point पे put करेंगे, that is Kp by R cube under root 1 plus 3 cos square 90. Cos square 90 is 0. Cos 90 is 0. So this we can write E equals to Kp by R cube 1 plus 3 into 0. This is 0 only. We can write 0. Under root 1 square root is 1 only. This is Kp by R cube. So we can write over here E equals to 1 by 4 pi epsilon naught P by R cube. Point to be noted, point to be observed. At axial point, field is 1 by 4 pi epsilon naught 2 P by R cube. Here 1 by 4 pi epsilon P by R cube. It means field at axial point is twice that of equatorial point. What is electric field at axial point is twice that of equatorial point. Okay, so here we can write 10 alpha. 10 alpha is half of 10 theta. 10 alpha equals to 1 by 2 into infinity. This is infinity now only. Infinite. If this is infinite, so then alpha equals to what? 90 degree. With what? R. It means field is along this. And this is R vector. So this is 90. If it is making, alpha is making with the position vector. So dipole moment is this one. Electric field is this one. So angle between dipole moment and electric field is 180 degree. So what we can write? We can write the direction of we can write here the angle between E vector and P vector is 180 degree. Hence E is anti-parallel to P for equatorial point. It means axial point, on axial point, electric field and dipole moment are in the same direction because theta is 0. At equatorial point, the angle between electric field and dipole moment is 180 degree. It means they are anti-parallel, out of, like in opposite direction. You can see this is the dipole moment, this is the electric field. Any problem? Very important concept, very important formula for competitive point of view. Right? This general point and equatorial point, right? Derivations you will be asked in board exam. 12th board exam, this field due to and potential due to dipole at axial and equatorial is there. But at general point, this derivations is not in board exam, but this is very important for the mains and advance. Okay, so here one more thing to be remembered. From here till here, done everyone? You can pause the video and you can understand, you can write also, make a proper note like you are studying in live class, you are studying in offline class. Okay, If I'm audible to everyone and if my voice is clear, if I'm teaching proper, and if you are able to understand from my video, just uh, share this video to you with your with your friends and with your family, whoever is required this type of video. You can comment in the comment section. Will make for you different new videos for your according to your requirement. Okay, we'll teach here whole the physics up to advanced level in this section. So here we can see electric field is direct inversely proportional to r cube due to dipole. For dipole, yes. One more thing, axial point. We know E axial equals to 2 kp by r cube. E equatorial is kp by r cube. It means E axial equals to 2 times of E equatorial. It means E axial by E equatorial equals to what? 2. So students, pause the video where I am fast and understand each and every concept, where what is going on and how is this derivations takes place. It means this derivations is not asked at any point, but the concept and how to approach the problem, these all things we can understand from the derivations only. Already I have told many times, derivations gives the steps how to solve the problem, gives the grip about the subject. You can enjoy the physics when you understand the concept only. Only formula, remembering formula is not a preparation of JEE Mains in advance. So all the best. Keep watching, keep commenting, sharing the videos and supporting me also. Thank you.